Bismillah ar-Rahman ar-Rahim. Sorry for that delay, Yani. We'll cover transport layer today. So transport layer or transport layer protocol, it's used for what? It's used for, if you remember from network 1, TCP. It's not used for DCP. Yeah, TCP or UDP are used for what?
Transmission packets.
Organizing the communication.
Yes, organizing the communication.
That's, yeah. So transport layer is responsible to facilitate the communication between two application endpoints end to end. Okay? So we will give an overview. Okay? We'll give you the full picture, and then we'll start to dig deeply into each of these functions for the transport layer protocol. As you can see here, the functions are multiplexing and demultiplexing, reliable data transfer, flow control, and congestion control. So we'll dig into each one of them. So we'll try to visualize at a high level what is the meaning of each of these functions for the transport layer protocol. Okay? So if we assume that we have a host, and host 2, these hosts are machines, actually laptops or desktops or something like this, right? Or mobile phone or something. These devices, hosts, they have an IP address, right? And they host multiple application endpoints. Okay? So there are multiple applications running on each host. Okay? In the middle between these two hosts are in general on the either side of the continent or the world. So they are really remote to each other. There is huge distance between them in general. Okay? So in between there is like some network interface on both sides, okay? And this network interface is connected with like some network, including edge network and core network, right? So there is some kind of access to the network, right? And in the middle there are wireless routers, switches, hubs, things like that in the middle, okay? So these application endpoints running on each host, they need to share this network interface, right? Such that the traffic coming from all these applications, it gets fed into the network, and somehow here, when you send it here, it goes to a particular application. Okay? So this is done through what we call multiplexing. So the traffic or the data, the high-level data coming from all these application endpoints, they go into the network using the concept of multiplexing. So we need to multiplex the traffic, okay? And there is a specific traffic here coming from this application endpoint. It needs to go to this application endpoint in particular, okay? A host is identified by what? IP address, right? Application is identified by what? Port number, bravo Ali. Yes, so the first thing is multiplexing and demultiplexing, and this is facilitated through the port number. So multiplexing and demultiplexing is the minimum requirement for any transport layer protocol. It has to be able to multiplex and demultiplex, which means that the minimum set of fields for any transport layer protocol are source port number, destination port number. Source port number identifies the sending application. Destination port number identifying the receiving application. Okay? So that's the multiplexing and demultiplexing, and this is the first and minimum function for any transport layer protocol. Okay? Reliable data transfer, flow control, congestion control, these are optional. Not all transport layer protocols have to have these functions. So what are these functions? Reliable data transfer guarantees what? Guarantees the delivery of the data that is going from the sending application to arrive successfully at the receiving application.
Does it guarantee the successful transfer?
Yes.
Or only the handshake?
No. Handshaking is related to connection-oriented or connectionless. We'll talk about this. Okay? Reliable data transfer here guarantees that every single bit of the data that we send
Will be successful.
should be arrived here successfully. But in order for us to do that, what is the mechanism? How do we ensure this? Through a. So when I talk to Muhammad, how can I confirm that whatever I'm sending to him is really received successfully by him? He should do this, right? So he should send me some acknowledgement, okay? So acknowledgement is the mechanism to provide reliable data transfer. So we'll talk about this and we'll get to the details of this and see how we can provide reliable data transfer. Or particularly the transport layer protocols that provide reliable data transfer, how do they do this? Right. Flow control and congestion control. What is the difference between them? So both of them talk about the fact that each application should send set of we don't call them packets, we call them packets is the protocol data unit from the network point of view, okay? So to be accurate, in the transport layer protocol, we talk about segments. Frames is data link. Transport layer protocol talks about segments. So when I tell you the term segments, you know right away that I'm talking in the level of transport layer. If I tell you packets, we're talking about network layer. If I tell you frame, we're talking about data link layer. If I tell you bits, we're talking about a physical layer, and so on. So this is the protocol data unit in each layer. Okay? So the application in general creates data, right? Data is like one unit, could be represented using HTML or whatever, video, audio, things like that. In order for us to facilitate the multiplexing and demultiplexing, we cannot multiplex a full video 2 gigs, sending them in one unit. This will take the entire network for a long period of time, right? And the network will be occupied through that period of time, and other users will not be able to send anything. So we cannot afford that. So the only way is to break down any data from the application into what we call segments. These segments, they get sent over the network. So this will facilitate the fact that we multiplex different segments from different application endpoints. As long as we, in this segment, we store the source port and the destination port, we'll be able to deliver this to the right application on the other side. Okay? Remember that when they get sent to the network layer also adds a IP address, right? The IP address. So we have 2 levels of addressing. In fact, we have 3 levels of addressing. We have the port, which identifies the application, IP, which identifies the host or the network, and we have the physical address or MAC address, which identifies the device itself. Anyway, the MAC address is not in the scope of our course anyway. Okay, so now we have some segments and they need to be delivered. So we talked about reliable data transfer. So for each of these segments, we need acknowledgement. Okay? And we will see whether we need it for one segment or for a group of segments, depending on the protocol. Right. Flow control, congestion control. What is the difference? Both of them, they talk about regulating the traffic from the sender. Okay? So if I say all the segments from one application will be sent over the network, طب ما كده ما عملناش حاجة. We didn't do anything. So we actually divided them into segments to facilitate the multiplexing. Now you're telling me I will send all the segments from one application, so I didn't do anything, right? So we need to regulate, to control the rate of transmitting these segments over the network. طيب. Both of them, they do this. طب what is the difference? The difference is that flow control regulates the rate of transmitting these segments with the purpose to avoid overwhelming the receiving application. Okay? In other words, the receiving application receives all these segments in a buffer. So we need to regulate the transmission rate to make sure that this buffer will not get full at any point of time, which means that the application consumes this faster than the speed of filling this buffer. واضح كده? So this is flow control. Congestion control talks about that again, regulating the transmission of the frames, or sorry, the segments, but with the purpose of not overwhelming the network. So this is the slight difference now. Okay? And you will see that this part changes the technique altogether. So the techniques that we use for flow control are significantly different from congestion control. We'll talk about the techniques used for both sides. واضح كده? So we talked about multiplexing and demultiplexing, which is the minimum requirement. Okay? Reliable data transfer, flow control, and congestion control. So congestion control here cares about the intermediate routers in the middle of the transmission. So if I send too much, right? So I will cause traffic jams. The highway will be blocked. Okay? So I cannot just have no limitation on the applications to send with whatever rate they want. No, the network in that case needs to limit or needs to send. In some cases, the network sends some feedback, but this happens in very limited cases. Okay? But we will see how we can, remember the application or the transport layer is totally agnostic to the topology or the logical or the physical topology of the network. I don't care how many routers exist in the network. If I don't care or I don't see, I don't have any access to how many routers inside the network between me and the end application, how would I know if I'm congesting the network or not? Makes it a little bit hard, right? So either the network tells me, or I need to have some implicit indications that there is somehow some traffic jam. This is the main problem in transport layer protocols, that they have to make certain assumptions. In many cases, transport layer protocols, they make assumptions. They are designed based on assumptions. And sometimes these assumptions are not 100% correct. And that reflects back on the performance. So we'll be able to analyze the performance of some of these transport layer protocols. And we can see that in some cases, based on certain assumptions, the performance changes significantly. Okay? This is the... تفضل.
I'm sorry, the assumptions are embedded in the protocol used?
Yes, of course. Yeah. It's like anything else. If I design something, I need to have a set of assumptions based on which I will design it this way. Because if the assumptions change, the design might change. Okay? If for example, the transport layer protocol is made aware of the network topology, the design will be totally different. But is that possible? In many cases, that violates the layered architecture أصلا. صح? We said that one fundamental thing, layers they have certain level of isolation, right? So in the transport layer, I should not see the details of how the network layer works. Otherwise, I combine both layers. In that case, the network function becomes much, much complex, right? So there is a principle of isolating the layers. So each layer has to make certain assumptions and certain interfaces to the lower layer and the higher layer in order to facilitate the design of the protocols in this layer. ماشي? So this is the high level. Okay? So let's dig deeper into each of these functions and see how it's done. Okay?
Doctor, you're talking about the flow control and congestion control in the network layer?
احنا بنتكلم اصلا ان جاء على الترانسبورت لاير ما بدناش سيره النتورك لاير. ترانسبورت layer. This is the transport layer. طيب. طيب. So transport layer services and protocols, they provide the logical communication, as I said, between application processes. The application endpoint, okay, it could be what? A router tap is an application endpoint. HTTP server, any HTTP client is an application endpoint. Actually, مثلا ايه الموبايل phone is mobile phone is a host. It hosts many hundreds of application endpoints. Any process or a thread that runs a certain logic, okay, and sends something on the network is considered an application endpoint. Okay, so even in the browser could be one application endpoint, or I could have multiple tabs. Each of these tabs, right, is a separate application endpoint. Application endpoint is defined by a source port, and it communicates to another end application which is identified by destination port. واضح كده؟ طيب. So again, the application endpoint on the sender side here, it breaks up the messages into segments, passes to the network layer. So this requires some kind of multiplexing and demultiplexing. So this is get multiplexed from multiple applications on the network. Then the receiving side will reassemble, which means that first it will demultiplex. All the segments will arrive here. Okay, depending on the transport layer protocols, part of the reliable data transfer is that not only I guarantee the successful delivery, I guarantee the order of how they arrive. Okay, so I cannot send 3 packets. Okay, 1, 2, 3, they arrive 1, 3, 2. No. Okay, some transport layer protocols, they guarantee even the order. Okay. So this will make it easy at the receiving side that we get all these 3 segments and then we reassemble them and get the original data. That's how it works, okay? So of course, TCP and UDP. In many networking courses, they always talk about TCP and UDP as the common protocols. In fact, TCP is one extreme and UDP is the other extreme. There are so many things in between. And we're talking about 2 extremes. TCP is provides the perfect reliable data transfer. UDP provides no data transfer whatsoever. Okay? In the middle, there could be multiple levels. Okay? So we'll talk about this. Type. What is multiplexing and demultiplexing? Multiplexing here, as we said, talks about any application level process, which we defined as the application endpoint. Okay? The transport layer protocol defines what we call a socket. A socket is nothing but a buffer which is used to store these segments to facilitate the transmission of these segments one by one. That's all, okay? This socket buffer has the source port and the destination port. And through the source port and the destination port, it facilitates by the multiplexing and demultiplexing. Okay? So process P3 may communicate to process P1, which runs on the same host. So this is the host. The host might have 2 processes or 2 application endpoints. Each one communicates with another application endpoint on another host. Okay? So that's how it works. One application process might in fact have multiple socket buffers. This happens especially if we're using an application process which works as a server. In that case, we will have multiple sockets communicating to multiple applications. Okay, so we'll talk about this scenario as well. So the main thing that we use is as we said, the source port and the destination. This is the minimum set of fields in the transport layer header. So UDP has it, TCP has it. TCP, of course, has other things as well, right? UDP has the source port and destination port and checksum. That's it. Okay? So very light. TCP has tons of fields. We'll talk about them because it needs to provide perfect, reliable data transfer, flow control, congestion control, and so on. So we'll see how this is done. Of course, when it goes to the network layer, then we add as well IP address, which identifies the remote host or the remote network that this traffic should go to. So this is the minimum. So the multiplexing and demultiplexing, depending on the protocol, it defines two types of socket. It's called the server socket or a datagram socket. Datagram socket is simply identified by destination port number only. Okay? Because this is the minimum requirement for UDP. UDP, I need to create the datagram socket to send to a receiving application on the other end. I need to identify only the destination port number of that application. That's all. Okay? But there is no concept of connection. So I don't have to do handshaking. I don't have to connect. Okay? So in the transport layer, we also have the concept of connection-oriented and connectionless, which kind of overlaps with circuit switching and packet switching. But here, we say that TCP establishes a connection before it sends. What is the benefit of this? We talked about the benefits of establishing a connection. That we can easily provide not only reliable data transfer, but we can easily also guarantee the order. Because if we establish an end-to-end logical pipe between two end applications, so we guarantee that these segments flowing into that logical connection end-to-end, they should arrive in order. Okay? But providing that at the transport layer has a little bit of overhead. We'll talk about them. It's different from network, from circuit switching and packet switching. So we'll see how this is done. But again, there are two types. Datagram socket, which is used by UDP. It doesn't establish any connection. It just sends the segments, okay, to a particular end application, which means that the receiving application theoretically will be able to communicate with multiple applications using the same socket. واضحة دي؟ Okay, so the application endpoint on the other side is identified only by the destination port. So if hundreds of applications are sending to that port, okay, the segments will arrive to the same application. I don't have to do any connection. Okay? So this is datagram socket, which means essentially that UDP does not provide any connection, and it's simple. Socket is identified by the destination port. As long as someone is sending on this destination port, it will arrive to that application. As simple as that. So this is how it's done. So this is what we call connectionless demux or demultiplexing. Okay? So this process is using this destination port number, and this process is using this destination port number. Okay? Regardless of anything, regardless of the source port number, regardless of the IP address, okay? If these two processes are sending using that destination port number, they define what we call a datagram socket with that port number, okay? The segments will be sent to this process on the same socket. The same socket buffer will be able to receive from two different processes. Okay? So if that's okay by the application can do that, and it will be the responsibility of that application to consume the traffic coming from multiple applications. Because sometimes that might create problems. But that's how datagram sockets are designed. Okay? Type. What is the other alternative? This is what we refer to as datagram socket. So forget about IPs, forget about source port numbers. These are irrelevant in that case. What we care about is destination port number only. Type. Alternative is that TCP socket, or what we call server socket, okay? The socket is identified by all these four pieces of information. Source address, source port, destination address, destination port. So if any of these fields is different, that creates a different socket altogether. Okay? So in that case, TCP has a server socket which maintains multiple socket buffers. Each one is identified by where it's coming from. So this is how this concept, by the way, of course, is used for HTTP servers, web servers. All the web servers, they create a connection with every client they communicate with. So even if you open 2 or 3 or 4 tabs on the browser, and all of them, google.com, 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 okay? All of them. Each one of them will have a separate logical connection with the server, okay? Why? What's different here? So I open 4 tabs, right? All of them, google.com, 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 which means that the same server, right? Which means the same IP address, okay? And the same destination port, okay? Yet the server will create a different socket buffer for each. Based on what? Source port, yes. So what's different here is source port. So even if the source port is different, I create different socket buffers. This is how it looks. Okay? So you can logically think of the server as a process that maintains multiple threads in that case. Okay? Each thread works or interacts with one socket buffer which communicates with one application representing the client or any tab that you open on the browser. Okay?
Victor, I just got confused here. When we created the three sockets
based on the fact that the source port here, to confuse you, we have the same source port here. Why? Because we are coming from different source IP address. What I'm trying to say is that these 4 pieces of information identify the socket buffer. If any of them changes, any of them, okay, then we have to create a new socket buffer. For this particular example, of course, they are coming from 2 different IP addresses. The example that I just explained to you is the extreme. Even if we're talking about the same IP address, you, on your browser, you open 2 tabs, 3 tabs, 4 tabs, 5 tabs, okay? And all of them, google.com, google.com. Even in that case, you will create 5 socket buffers on the server and 5 socket buffers on the client and on the server. So your browser will have 5 socket buffers, and google.com server will have 5 socket buffers. Each of the tabs is communicating with the remote socket buffer. Why? Because each of these tabs, once you create a new tab, the operating system will assign a source port different from all the other tabs. واضحة؟ So any piece of information in these 4, here, of course, the source port number here and here, they happen to be the same only by coincidence, huh? Because these get assigned locally by the hosts. The operating system assigns this. So this example tries to explain to you that even if the source ports happen to be the same, which are assigned locally on the hosts, the IP address is different, therefore I should have different socket buffer for each one. Okay? If the IP address is the same, right, then the source port will have to be different. In that case, we will also create new socket buffers. But these four things, if any of these numbers change, then I have which means I have a separate connection, separate logical connection, right? Having this logical connection is somewhat beneficial in maintaining the order of these segments. So whenever I send these segments, okay, I make sure that they arrive here in order. Okay? It does not necessarily provide reliable data transfer until now, except if we support within this logical connection, we need extra thing, acknowledgement. So we need to send acknowledgement for each segment we send from the source to the destination. That's an extra thing that we have to do. واضح كده؟ So that's the difference between connection-oriented and connectionless. As I said, you could have like a big process that instantiates multiple threads. Each thread will maintain one socket buffer, right? Or you could have separate processes, okay? So HTTP server is an example of this. You have one big process that has a server socket which maintains multiple socket buffers. Each communicates with different application endpoints. Okay? Because of course, as we said, client-server model talks about one-to-many. So a server serves multiple clients, right? So how does the server do that? By maintaining this logical connection with each client. And in that case, you have to use a server socket. Type. That's the easy part. So now we'll take a deep dive into reliable data transfer. So how do we provide reliable data transfer? So the idea here is that it's important in the applications to provide some level of reliable data transfer. So if we were to assume that there is a sending process, lower sending end application and receiving end application, and the channel underneath this channel is the network. For us, is the network topology, or between the two application endpoints, there is some network, access network, edge network, core network, right? So this network topology, it happens to be inherently reliable, which means that the IP protocol itself at the network layer, okay, guarantees 100% reliability. Is that the case for the internet? No. Okay. So this is a huge assumption, which not true. Now we know it's not true. But if hypothetically this assumption is true, then the transport layer protocol needs to do what? Multiplexing. That's it. Because everything else is guaranteed by the network. Okay? The bad news is that's not the case. Okay? So we need to do some homework here. So that if the channel is unreliable, this will determine the complexity of the reliable data transfer that we need to provide back from the transport layer protocol. This is one of the biggest functions of transport protocols. So if the network channel is inherently unreliable, okay, then it becomes, this is by the transport layer. Then it becomes the function of the transport layer to compensate for the lack of reliability from the network layer, right? So we need to do some logic here, okay, to account for the fact that the network layer is inherently unreliable, which is the case, okay? But even this, it's not a 1-0 thing. It's not a binary thing. It's not reliable or unreliable and that's it. There are levels. Okay? And there is some levels of unreliability, if you will, يعني, at the network layer. Okay? Or as we said, some assumptions that we have to make on the network layer in order to facilitate the design of that transport layer. Okay? So we'll go with these assumptions step by step because we want to go through the thought process, how the transport layer protocol should provide this reliable data transfer, making these assumptions. So the more realistic assumptions you will do, the more complex the transport layer protocol needs to be. واضح كده؟ So we'll go step by step because we want to really be like some scientific. You want to think scientifically and really know how we can design this reliable data transfer aspect, making certain assumptions on the channel of the network. Type. So there is, the transport layer protocol, we call it a reliable data transfer. So RDT stands for RDT. So RDT stands for reliable data transfer. So then the transport layer protocol needs to provide the function of reliable data transfer send. So this function is triggered by the application. So the application here, so the application running here will send this will trigger this function, which means essentially the application will put a segment in the socket buffer. Okay? And then the transport layer protocol will say, oh, okay, I got a new segment. Okay, I need to activate the function that is called reliable data transfer send. This function will have to do certain logic, okay, in order for the end, at the end, it needs to send unreliable data transfer send over the network. So the network is inherently unreliable, which means that the network provides to you the interface or the service that the network currently provides to you is a function called unreliable data transfer. I don't account for any reliability. Okay? So you need to account for this reliability at this level. How do we do this, Ba? That's the question. Okay? And here, Ba, we say that reliable data transfer receive, which is activated in the transport layer at the sending side, at the receiving side. This reliable data transfer receive, okay, will then perform certain logic to make sure that this segment is indeed successfully delivered. Okay? And then it delivers this data to the application. تفضل يا عم, this is the segment, and this segment is coming in order. It's not duplicate. It arrives correctly. Okay, it's not corrupted. All these are part of reliability, right? It's not the same packet that you received before, I can assure you this. This packet or this segment is not corrupted. This packet is a new packet. So all of this have to be confirmed. So this is what this function will do. واضح كده؟ طيب. So getting started, so we need to, as we said, we need to make certain assumptions, and based on that, we need to design these functions. Reliable data transfer send, reliable data transfer receive. Basically, okay? So reliable data transfer send called from above. Reliable data transfer send is what we say event triggered. Okay? Event triggered معناها it may be triggered asynchronously at any point of time, because we don't have control when the application will give us that segment. Application will put the segment in the buffer and that will trigger the event. Okay? But when the application will put it in the buffer, we don't know. So this is called a event-based. ماشي? So reliable data transfer send is called from above by the application, event-based. This is done synchronously, which means that after finishing the logic here, I will call the unreliable data transfer send. I will call it. ماشي? Same thing here. This is again, event-based. Because we don't know when we receive the packet. We don't know when the packet will arrive, if any. Maybe it will never arrive. Okay? تمام. طيب. What's our tool to design? Yeah, if you were to be the scientist who is designing that transport layer protocol, okay? We need to model. يعني the first thing, and it's very key, by the way, you will learn this a lot, especially in your degree. How to model a problem in order to be able to design the solution. So the first thing that you do is that you work on a model, okay? So the way for us to model the function of the transport layer protocol is what we call a finite state machine. Finite state machine, maybe some of you or many of you, you know already what finite state machine is to try to represent any functionality into states that this system may take, okay? A state is defined by certain situation that currently the system is taking, okay? It might change after a few seconds or a few milliseconds, right? So I need to represent the different states of that system using this node, right? And then based on certain events, based on an event, okay, I need to do certain actions. These actions, okay, may result in the fact that the system will move from one state to another. Why am I saying may? Because I may actually perform certain actions and stay in the same state. Okay? So the actions will not certainly move you to another state. It may send you to another state, and it may keep you to the same state. واضح كده? So this is basically finite state machine. Many problems. It's used in many disciplines. In mechanical engineering, in software engineering, in all disciplines, computer science, algorithms, many things. ماشي? So that's finite state machine. So we want to use finite state machine as the tool to approach how we design the reliable data transfer protocol. So we will start with reliable data transfer 1.0. What is the assumption here? The assumption is simply the underlying channel is perfectly reliable. We don't have to do anything. If the underlying channel is perfectly reliable, all we need to do is just to make packet, send. What is make packet? Make packet, it will take the segment from the buffer, adds the source port and the destination port, and off you go. That's it. Okay? We don't have to do anything special, right? And we are sure that the reliable channel will guarantee all levels of reliability, the order, and everything. And on the receiver side, we will extract. Extract here will do the opposite. We'll take the header from the segment, throw it away, just read the destination port number, and deliver it. Deliver data will deliver it to the end application that has this destination port number. That's all. Very simple. We don't have to do anything in between. واضحة كده؟ سهلة. طبعا we don't have to model more than one state because I'm always in the state of wait for call from above, wait for call from below at the receiver side. Call from above, once the application sends me a segment in the buffer, fetch this segment, put the source port, destination port, send it on the channel, it will arrive successfully 100%, right? On the other side, I have an event triggered, I take that segment, throw the header away, take the data, send it on. That's it. And I'm always in the same state. I don't have to move from one state to another. واضحة دي؟ سهلة جدا. طبعا of course our assumption is a very perfect assumption, and it's realistic. So what is a more realistic assumption? The other level is Okay, so we assume that the channel guarantees the delivery of the packet, but it doesn't guarantee the correctness of the packet when it arrives. واضح الفرق؟
correctness you
The
mean?
correctness يعني معناها all the segments they will arrive on the other side for sure 100%.
Corruption.
But they may arrive with some bits in error. أهي. Channel with bits in error. Okay? For us, compared to the previous one, that's a significant upgrade. Okay? So the channel will guarantee the delivery of the packet, but it doesn't guarantee the correctness of the packet. So in that case, okay, so as you can imagine, all we need to do is just to acknowledge whether the packet, acknowledge to the sender. When the receiver receives the segment, it will need to acknowledge whether this segment is correct or not. Okay? So we have two states or two possibilities. Either it arrives corrupted or it arrives uncorrupted. Do we have any other state? We don't have any other possibility because it has to arrive. Okay? خلاص. Okay. So again, through the thought process, you might think, okay, so خلاص, I will send acknowledgement or negative acknowledgement. If it arrives correctly, I will send acknowledgement. If it arrives incorrectly, I will send negative acknowledgement. Okay? Acknowledgement for the sender means what? Everything is fine. خلاص. Okay? Arrives incorrectly معناها ايه؟ Send again. Retransmission. That's the only way we guarantee reliability in that case. Okay? Very simple. طيب. Again, is that assumption a strong assumption? Of course. Yeah. We'll go step by step. So in that case, the sender will say, okay, so reliable data transfer, what it will do is that when I receive a segment from the application, if I see a segment on the buffer, in the socket buffer, I will take this segment, make the packet, send it. Easy. Okay? So when I do this, I have to wait for an acknowledgement. That's another state back. Okay? طيب. Remember, here, I have to send one segment and receive the acknowledgement before moving to another segment. Right? This is similar to, if you remember from network one, the stop and wait. So I'm handling one segment at a time. يعني handling more than one segment at a time, we'll not discuss it today خالص, and we'll discuss it next time. Because that's another level of complexity. Okay? So make the packet and send it similar. But here I have to wait for an acknowledgement. Why? Because the channel is somewhat unreliable. Okay? So that's why I have another state here. So which means that if يعني when I'm in the state of receiving acknowledgement or negative acknowledgement, can I send any other packet? No, I cannot send anything. I'm just in one state. Okay? So when I'm waiting for an acknowledgement, either I receive acknowledgement or negative acknowledgement. There's nothing else. ماشي؟ طيب. So if I'm waiting for acknowledgement or negative acknowledgement, if I receive negative acknowledgement, خلاص ما تنفعنيش لا. I have to send the packet and wait for acknowledgement. Send the packet and wait for I will have to do this forever until I get positive acknowledgement. Okay? Because here I'm providing 100% reliability. ماشي؟ طيب. So if I receive negative acknowledgement, I will send and I will loop in the same state. Okay? Only if I receive one acknowledgement, okay, receiving one acknowledgement, I will have to go here. Right? I don't have to do anything in that case. Phi here stands for nothing. I don't need to do anything. خلاص, successful. Packet is delivered. Okay? I don't need to do anything. I will go here and wait for another segment. Mission accomplished. تفضلي.
When we say wait for call from our means,
From the application.
is already established. I'm just waiting.
صح. كلامك صح. صح. كلامك صح. Yes. So the connection has been established already. That's out of the scope of this. Here we're talking about reliable data transfer, assuming that the connection is already established. We'll talk about how we establish the connection in a later stage. Okay? And on the receiver side, I'm receiving the packet. Okay? I'm receiving the packet. If the packet arrives correct, send acknowledgement. If the packet arrives incorrect, send negative acknowledgement. But in all cases, I'm only waiting for the packet. That's it. So that's why we have just wait for packet from below. That's it. Okay? So we only have one state. I have to also say that you can design these finite state machines slightly different, by the way. Okay?
Doctor, why are we saying a packet, not a segment?
The packet ايه؟
Why are we saying a packet, not a segment?
معلش انا زلت لساني. المفروض ابقى consistent all segment. Yes. You're correctly right. You're perfectly right. So if the segment arrives corrupt, I send negative acknowledgement. If the segment arrives not corrupt, I send positive acknowledgement. That's it. And of course, I have to deliver. So deliver the packet, deliver the segment up, and send acknowledgement. Or send acknowledgement and then deliver the data up. Doesn't matter. The sequence doesn't matter in that case. Okay? Type. So that's how it works. So send will make the packet, will send it, which will trigger this event, reliable data transfer receive. If it's not corrupt, then I will deliver the data up and send the acknowledgement. If it then when it arrives here, I don't have to do anything. Or the other path, if it triggers here, receiving with corrupted segment, in that case, I will send negative acknowledgement. But in all cases, I will loop through the same state. And this will arrive here, will trigger this event, which will send the packet again and loop for the same state. So that's the sequence, yeah. So this is the sequence. There is an implicit thing here which we didn't account for. If the packet is sent over the channel, can anyone guess what is the problem here?
Corruption acknowledgement.
The acknowledgement.
يا منع برضه يعني it's good برضه to have people who are really يعني alert. Okay, so the same channel that corrupted the segment may in fact corrupt the acknowledgement, because if the channel can corrupt thing on one direction, it may corrupt on the other direction, right? Which means that the sender now receives acknowledgement or negative acknowledgement, okay, but it's corrupted. Corrupted means I cannot read it. I don't even know whether it's an acknowledgement or negative acknowledgement. Okay, so what should I do now?
Resend the data again.
Yes, but does that mean that the data did not arrive successfully?
We don't.
We don't know. That's the penalty now. So you have to make an assumption. You have to make an assumption that the data that I sent was not delivered, even if it was. Okay? So what is the implication of this?
I'm not saying the same thing.
So which means that the receiver will have a
Application.
duplicate packets. Oops. Okay, so that's a situation now. This is a situation now. So this is what we call stop and wait. Okay? So if we make the assumption that the channel is reciprocal means what? That whatever possibility of error in one direction may happen on the other direction. Reciprocal, right? Which makes sense, right? Then we have another phenomena now, which triggers us to have to think about dealing with duplicate segments arriving on the receiver. Duplicate segments, how can we detect that it's duplicate?
Do we need to detect if it's duplicate at transport layer?
what is the other alternative?
I can just let the
You mean
application
the
layer
net-
handle
in the
it.
network or in the receiver?
So again, I mean, for people who are not visualizing the dilemma that we have. So this is the sending application. That's the receiving application. Sending application is sending one segment. So there is a possibility that this will be corrupted at the receive. It happens that it arrives successfully. So the segment was received successfully, right? And then I send the acknowledgement, okay? The acknowledgement was received in error, okay? The acknowledgement was corrupted, not the segment. Okay, so I will have to send the same segment again, right? So the receiver now has these two copies of the same segment. Okay? How do we detect that these two segments are duplicate? Checksum
Number acknowledgement.
checks whether it's corrupted or not. I forgot to say that. How do we identify whether the data is corrupted or not? Through the checksum. بالضبط صح. This is something I forgot to say. That's our way of detecting the corrupted segments. So we assume خلاص the segment was not corrupted. But now, how do we detect that this segment is duplicate?
Acknowledgement.
ها؟
Acknowledgement number.
لا لا مش الاكنولجمنت نمبر بقى هو نمبر صح but it's the number in the segment not the acknowledgement لا the number in the segment
Oh,
yeah the number in the segment so in the segment I should have a sequence number okay ما حدش يجي يقول لي ايه check the content which means that يعني get back inside the video and check whether the actual data is لا لا this is not the transport layer function
The sequence of bits.
yes the transport layer deals with sequence numbers. Okay? Because you may have the same content sent twice from the application. هو application نوع عايز كده اعمله ايه؟ So for the transport layer, okay, duplicate segments are detected through sequence number. But the idea here is that how many sequence numbers do I need in that case? يعني all the segments should have a sequence number. We agree on this, but how many sequence numbers, how many different sequence numbers we need? In that case, we identify two possible states. There are no third state. Either these two, the segments arriving contiguously, or the segments arriving to the receiver are either different or the same. صح? We don't have a third possibility here. Why? Because here we're talking about sending one segment at a time. Okay? So how many different sequences we need? Two. Which means that the sequence, so the application will have segments, right? Okay? It will put a sequence number 0, 1, 0, 1, 0, 1, 0, 1. I don't need any other sequences, right? So there is no way I can send this segment and this segment will never have this situation, okay? But we can have this situation. They will arrive to the receiver at the same time. So the receiver needs to distinguish that these are different. And there could be this same segment sent duplicate. In that case, I need to identify that this is duplicate. Okay? So we need two sequence numbers only. 0, 1, 0, 1, 0, 1. That's it.
Doctor, if I'm using Superman, how can you explain how will I send segment 1 before segment 0?
Segment 1 before segment 0? No, well, the idea is that the idea is that when the receiver receives signal 0 and then receives signal 1 after that, okay? خد بالك, between segment 0 and segment 1, what did the receiver do?
Wait.
لا it sent an acknowledgement صح for segment 0 right صح but the receiver doesn't know whether this acknowledgement arrived or not. How will the receiver know that the acknowledgement arrived successfully? The only way for the receiver to know that is to look for the next segment. If it has a sequence number 1, then the acknowledgement was received successfully. If it has a sequence number 0, then the acknowledgement was not received successfully or was corrupt. صح?
But who will know this, the receiver or the sender?
The receiver.
The receiver.
Yes. That's why we need these two sequence numbers only. So if the receiver receives 0 and then 1, then it knows that it's going in order and everything is fine. If they receive 0 and then 0, no, there's a problem here. Okay? And the receiver in that case will assume that the first acknowledgement was not received successfully. Okay? So it will send the acknowledgement again. Okay? So this is our way to provide a reliability for the acknowledgement. واضح؟ ماشي؟ Or to send the acknowledgement for the same segment twice, or maybe 3 times or 4 times. تفضل.
So at receiver, it received 0. And
Right.
let's say it received another 0.
Right.
So it will send
Acknowledgement.
acknowledgement
Yes.
again.
Yes.
And this, how to say that this acknowledgement belongs to the first 0, not the second 0?
They are the same. If the receiver receives 0 and then 0, they are the same segment. They cannot be a different segment. They are the same segment for sure. There's no situation that I receive 0 and then 0 and they are different segments.
Stop and wait.
Those two are the same for sure, 100%, because this is stop and wait. We send one segment at a time.
Okay, so stop and wait guarantees this.
Yes, guarantees this order.
Yeah.
And it's one segment at a time. So the only possibility is that either I have the same segment or 2 different segments.
Yeah.
Okay? So I need 2 sequence numbers only. ماشي كده؟ طيب. That reflects on the design. You start to have a little bit complications. Yeah, more complex design. So that's why, so this is the whole motivation behind the fact that now we need 0 and 1. So we need to have logic for 0 and logic for 1. Luckily, we see that it's like it's the same. Now we wait for call 0 from above. Okay? Or we wait for call 1 from above. But if you look here, you'll find that there is a mirror. So the upper part is the mirror of the lower part. Okay? So I receive 0. I send the segment. I go to wait for acknowledgement or negative acknowledgement for 0. Okay? When I receive the acknowledgement or negative acknowledgement for 0, then and only then I go to 1, and so on. But if I receive negative acknowledgement, then I have to send the same packet and similar to the previous one, okay? Except that here I have to do the same logic twice. One logic for 0 and one logic for 1. Okay? So that's the main difference here. Of course, you may design this slightly differently and select as a designer to combine those two. But you will find that you have to account for more complex design of the actual actions that you have to do. If statement, I have to add if statements and so on and so forth. Okay? But it's possible. It's possible. But here, we see that there's no if statements here, خالص. In the actions, there's no if statements, خالص. Okay? So the actions are straightforward. So all the ifs and stuff like is actually defined implicit in the state. Okay? If we don't do this, then we say if the sequence number is 0, then we do this. If the sequence number is 1, then we do this.
Yeah.
صح? This is another alternative design. We could do this. In that case, your function will have to be a little bit more complex. But it's possible. ماشي? So this is stop and wait. So that's more realistic. That assumes that the channel can corrupt either the segment or the acknowledgement. Okay? Type. Again, just be aware that the way that we check the correctness of the data is through what we call the checksum. The receiver will have to also have two states now instead of one, right? And for each state, we will have the same events that happened before. If the segment arrives, if segment 0 arrives, if segment 0 arrives and it's corrupted, then we send negative acknowledgement. Okay? If segment 0 arrives, if segment 0 arrives and it's not corrupted, but it's sequence 0, right? So this means that, yes, what I'm expecting, I'm receiving. صح, but everything is in order and it's not corrupted as well, so I will send the acknowledgement and send it up to the application. So everything is correct. This is the new thing now. So this logic is new here. That instead of receiving, we receive the segment and it's corrupt and the sequence is 1. Okay? So in that case, we will send, so this is accounted for. Okay. So here, this is, I waited for 0 from below. I received sequence 0 from below. So that's correct. Here, I received 1. Okay. So this is the new logic. صح. I received 1. I was expecting segment 0 to arrive, but I received sequence number 1. That's not what I'm expecting, right? 1 خلاص has finished before, but I'm receiving 1 again. So here I will assume that the first acknowledgement that I sent was not received by the sender correctly, in which case I will send acknowledgement again. Okay? So this is the new thing that happened in that case. And I will do this as well for 0, and I will do the same for 1. واضح كده؟ Any questions? ماشي؟ طيب خلينا break a little bit. Okay, so some discussion regarding the 2.0 version that we just went through. Of course, the sender needs only, as we said, needs only 2 sequence numbers, 0 or 1, and we answered why. Why we don't need more than 2 sequence numbers. And it must check if received acknowledgement or negative acknowledgement. If it's corrupted, that's a new thing now that we had to do. And because of this, we have twice the number of states, as it needs to remember it needs to distinguish between segment 0 and segment 1. And that's why we had this mirror design. On the receiver side, it must check if the received packet is duplicate or not. That we have to, and that's why we have the 2 sequence numbers. And the receiver cannot know if the last acknowledgement or negative acknowledgement received okay. But does it have to do this? We said that there is a work around this. So there is an implicit work around this situation that if it receives segment 0 and then segment 1, so it may assume that the previous acknowledgement was received successfully, for sure. But if it receives segment 0 and then segment 0, okay, then that must be because of the fact that the acknowledgement that was sent before, it was not received successfully at the sender side, okay? So we don't explicitly have to know whether the acknowledgement arrived or not. We can derive an assumption based on the segments that are arriving from the sender. So there is a slight upgrade. So if we were to talk about reliable data transfer 2.2, and we want to make it negative acknowledgement free, the idea here is that can we just get rid of this negative acknowledgement, because it's another extra, control message that we have to send. okay, can we get rid of the negative acknowledgement, which means that we can sort of indicate the fact that the packet was actually corrupted, يعني it arrived incorrectly, without sending negative acknowledgement? Can we do that implicitly?
We can create a timer
No.
or send
لا timer.
acknowledgement.
لا timer. The logical thinking of the timer is that I should expect something to arrive, okay, but it may never arrive. But is that the case here? No. Why? Because the channel will always deliver the segment. So the segment will always arrive.
So I will repeat the last
But
acknowledgement.
it may be corrupted. Okay? Okay. So we'll talk about the fact that it may never arrive, which means that we will need what we just said. But for now, we just want to answer the question: Can we implicitly send a negative acknowledgement without having to send a negative acknowledgement?
Yes.
Okay? And the idea here is yes, because of the fact that we have sequence number. Okay? If things arrive in order, okay, and it's corrupted, I can send the acknowledgement of the last segment that arrived not corrupted, which means I send duplicate acknowledgement. Okay? So that may implicitly give the trigger to the sender that the sender needs to send the same segment again. Okay? So that actually simplifies the logic. Okay? So this is a slight upgrade that we can do. So the main difference here is that I'm waiting for acknowledgement 0, right? يعني here I received the packet, but it's corrupt. I received the packet, the segment, okay? But it's corrupt. This is the sender side. Let's look at the receiver side first. So I'm waiting for 0 from below, okay? I'm waiting for 0 from below. Layer segment 0 from below. I received the segment and it's corrupt, okay? And the segment has sequence number 1. In that case, I will send the same packet again. But here, let's see here, this case. I'm receiving the segment coming from here. What's this state? It's wait for 0 from below, wait for 1 from below. I received the packet and it's 1, right? And it's not corrupt. So in that case, extract the data and send acknowledgement 1. So this is the case. So what is the case I'm talking about here? So wait for 0 from below. So I receive the segment and it's corrupt. So instead of sending negative acknowledgement, I will send positive acknowledgement for 0. Okay? So here, if it's corrupt or if it has sequence number 1. If it has sequence number 1, then I should also ignore, because this is duplicate packet. Okay? So in both cases, I will send the acknowledgement for the previous one, which should have a sequence number of 1 in that case. Okay? So this is a very trick. So I can ask you, masalan, in the exam I can ask you, what is the sequence number of the acknowledgement here? Okay? It doesn't mention it explicitly. What is the sequence number of the acknowledgement? It's actually the sequence number of the last successfully received segment, which in that case should be 1. Okay? So here there are two cases. The first case is that I received the segment and it's corrupted. I don't want to send negative acknowledgement, right? So I'll send positive acknowledgement with sequence number 1, which is the previous one that was received successfully. Or I'm expecting the segment 0, but I receive segment 1. So for me, this is a duplicate segment. Okay? So this means that the acknowledgement that I sent before did not arrive successfully at the sender side, right? So in that case, I will send the same acknowledgement برضه. واضح الفرق؟ The scenario 2 is that this is the scenario 2 is actually what we talked about before. It's the duplicate packet, the duplicate segment. Okay? If my previous acknowledgement was not received successfully at the sender side, okay, then I will receive the same segment again. I will receive the same segment again from the sender. This is the receiver side. Yeah, it's maybe confusing. This is the receiver side, and this is the sender side. Okay? And here, for simplicity, because we said that for the sender side, we have both are mirrors to each other. So there is like a cut through, and we're only providing one part of the sender and one part of the receiver. Sorry, I should have said that in the beginning. معلش. واضح? So this is actually the receiver side, half of it. And this is the sender side, half of it. واضح كده الأمر؟ Okay. So on the receiver side, I received a segment and it was corrupt. Okay? I don't want to send negative acknowledgement. So I'll send positive acknowledgement with a sequence number of 1, which is the previous one, the previous segment that was delivered successfully. Or I'm expecting segment with sequence number 0, but in fact, what I received has sequence number 1. Okay? So this means what? This means that the acknowledgement that I sent before, which had sequence number 1, did not arrive successfully at the sender side. واضحة دي؟ Again, yes, this is the receiver, right? And if I receive a segment at the receiver with sequence number 1, but I'm waiting for a 0. So this tells you what? لا, the sequence number in the segment that I just received is actually 1. But I'm waiting for 0. Here, the state is waiting for 0. واضح?
If you're waiting for 0, but you received 1, what does it mean?
What it means is that this is a duplicate packet. I received it before.
Okay, because I am a receiver.
Yes, I received it before.
Okay.
But maybe I'm receiving this one, not maybe. For sure, I received this one again because my acknowledgement that I sent before was not received by the sender correctly. So these are but here, these are grouped. I could have split this into two states, right? But here I chose to combine those 2 states into one because the action that I will do is the same. For both cases, the action that I will do is to send the same acknowledgement again. Okay? So either I receive a duplicate packet or I receive a new segment, but in error. In both cases, I will send the previous acknowledgement to indicate that, okay, so I'm telling you, the last segment that I received successfully is actually 1. Okay? So this tells you what? Send 0 again. صح? This tells you send 0 again. Yes, that's what you want to do. Okay?
يعني the sender sends a segment, right?
Right.
With the sequence number 0. This is the first segment. Right. We receive the acknowledgement from the receiver.
Right.
Correct.
Correctly.
Okay. Correctly.
صح.
And then he sends me segment 1.
Right.
And it's corrupted. صح?
Yes. Send segment 1, and it's corrupted.
Right.
If the receiver receives segment 1 and it's corrupted,
Yes.
okay. This will first, if you send segment 1, it's corrupted, it will actually trigger this state, not this state. Because here the receiver should wait for segment 1.
Right.
صح?
Yeah.
If I receive it at this state, which does not exist, if I receive it at this state, I'm expecting segment 1. It arrived and it's corrupted.
Right.
Okay? So this tells you what? send acknowledgement, huh?
Zero.
0 again.
Okay. So the receiver will send acknowledgement 0
0 again.
to indicate to the sender to send again.
Yes, to send again segment 1, right?
Yeah, understood now.
ماشي كده؟ So there are so many يعني scenarios here, so we need to follow it. Type on the receiver, sorry, on the sender side. If I'm waiting for acknowledgement 0, and then again I received a segment or I received an acknowledgement and it's corrupt, okay? Or is the acknowledgement is 1? Again, in both cases, I will send the same segment again. The previous one, I will send it again. That's it. Well, so this actually corresponds to this. ماشي كده؟ طيب. This is بقى the more realistic one. اللي هو full stop and wait. The full stop and wait assumes a practical channel which may corrupt or lose the segment. This is the more realistic one. ماشي? So there is a new assumption. The underlying channel can also lose the packet or delay the packet. ماشي? The delay may be forever, which means that it never arrives. In that case, I cannot wait forever. Only in that case, I cannot wait forever. So I have to have a timeout. The sender waits for a reasonable time. This reasonable time, by the way, is very tricky because that time is a design parameter that we need to really discuss very well. So if I wait that reasonable time and I do not receive the acknowledgement, what does that tell you? This tells you that maybe the acknowledgement was lost on the way. Lost بقى, not corrupt. Lost. Okay? But again, do I have any other choice? I will retransmit. Okay? So the main thing that we need to account for here is that there is another event that may happen, okay, which gets triggered by this timeout. This is the main thing that we need to tailor for here. Okay? There is another event, new event now, that when I send a segment, I should always set a timer. Okay? And this timer will fire after a certain period of time. Okay? When it fires or when it's expired, that triggers another event, which is the timeout event. Okay? If this timeout event happens at the sender should send the same segment again. Okay? Let's see whether we need that timeout at the receiver side or not. Does the receiver need to also expect the transmission of the segment within a time? لا, we said that the transmission of the segment happens asynchronously, صح? So the receiver should not dictate a certain time and expect that the segment will arrive in this time. No. So the receiver will most probably not need a timeout. Okay? And as we said, the receiver may send the acknowledgement and it gets lost. Okay? But it doesn't have to set a timer for this. It may derive the conclusion that the acknowledgement was lost or corrupted by the sequence of the upcoming segment. If the upcoming segment sequence number is the same, then the acknowledgement that I sent is either corrupted or lost. And for me, it's the same thing. Okay? So I should send that acknowledgement again. So here, the only thing that we need to carefully address is that concept of timeout. Yes. Okay? Type. So this is the main thing, and that's what we need. So what we need to carefully design now is whenever we send a segment, we have to start the timer. Okay? Once we start the timer, there are two possible things. Either I receive the acknowledgement before that timer expires. In that case, you see and I stop the timer. خلاص? Or the timeout expires. That's a totally new event. That's a totally new event. Okay? In that case, I will send the same packet again and start the timer. Okay? So this is the main difference. Type. That's understandable. So let's talk about a very interesting scenario that might happen. So a sender sends this is a receiver. A sender sends the segment. Okay? So this is the segment. It arrives successfully. And the sender waits for a timeout. Okay? The timeout expires here. The receiver sent back the acknowledgement.
After the time.
Okay. So I waited for a certain timeout. Okay? If the timeout expires, I will send the same segment again. Okay? That's okay, because we have a sequence number, 0 or 1, and the receiver will notice this. Okay? But after some time, I received the acknowledgement for the segment that was sent twice. I received that acknowledgement again. What do I have to do here? The sender. What does the sender have to do here?
Nothing.
Go to
Bravo.
the next.
Yes. Okay. Nothing. Okay. But it needs to know from the sequence, it needs to know that this is by this is a delayed acknowledgement. And I already retransmitted the packet, so nothing needs to be done. Okay?
Can it know it's delayed? Can it know if it's delayed or not?
No, it's not.
It doesn't have to.
It doesn't have to.
Yeah, it doesn't have to. Why? Because when I send the same packet again, okay, خلاص, this arrived. Do I have to do anything? No, خلاص, I retransmit it.
Exactly.
Okay, خلاص. So I take this packet and I throw it away, and then I go to the next packet, next segment. Okay. So these are the scenarios for this stop and wait. Sender sends, receive, send, receive. This is the happy path. Life is good, it's clean, no events happen. Okay, no adverse events. Okay? I could send, receive acknowledgement, send another packet, it gets lost. That's okay. I'll wait for a certain time. Time out, resend the packet. Oh, no, okay. No issues. Okay? Sender sends the first segment, arrive the acknowledgement, send the same segment, acknowledgement was lost. The acknowledgement was lost. Okay, that's fine. For me, I will send. The only difference here, the only main difference here is that the receiver has to detect the duplicate segments. And it knows how to deal with that because of the sequence number that we have. No big deal. Okay? There's no issue. Here, but this is the scenario that I'm talking about. So the packet, the segment was sent, and the timer fired before the acknowledgement arrives. Okay? So in that case, when the timer expires, I will send the same packet again. So I receive the acknowledgement. Okay? I don't have to do anything, just switch to the packet segment 0 and move on. There's no issue. Okay? The only cost for this, and sometimes this is a significant cost. What is the cost here?
Retransmit.
I retransmitted unnecessarily. What is the implication?
Overwhelming the network.
Overwhelming the network with unnecessary segments, which means I'm not using the channel efficiently. Okay? So there is the concept of premature timeout. Okay? That's why this reasonable time is really key. Is really key. Okay? So we need to calculate this reasonable time very carefully. Because if it's too long,
Waste from the segment.
you are also wasting the channel. The channel is empty and you're not sending anything. And if it's too short, you're wasting the channel with duplicate segments that you send unnecessarily. Okay? So it has to be reasonable. And reasonable has to be calculated carefully. Okay? So we'll be able to calculate this timeout, and we'll know how TCP in particular calculates this timeout. So
Maybe this time I should start very long. Once it knows like how much it need time for the acknowledgement, then fix it to that.
not like that. Not like that. Because again, this timeout, we know that this timeout actually over time it might change.
With every packet.
Not with every segment, but it needs to change. Why? Because based on the load on the network, the segment or the acknowledgement may get delayed or may arrive very fast, صح? So in that case, we need to also reflect this on the calculation of the timeout. So some calculations have to happen, yeah. ماشي? But before answering this question, how can we calculate the performance of that stop and wait 3.0? We did that also in network 1 before. So the idea here is that how efficient stop and wait is. Okay? How efficient means how often does it use the channel? Okay? So in order to answer this, let's see. So if I have, this is the time. So this is the sender, and this is the receiver. Okay? The sender sends, when it sends the first segment, okay, the segment gets sent. And remember, this segment has a significant length, right? So it can be represented like this. This width is the length of the segment, or it's proportional, because this is time, the length is proportional to the transmission time. So this is the transmission time of the segment. Okay? Why am I drawing this diagonal كده? To account for that. What is that time from here to here? Okay? So this is this is the transmission time. So this is the transmission time. What is this? Propagation time. This is the propagation time. So this is the time where the segment gets converted to a signal, and the signal propagates through the network, okay, all the way until it arrives to the receiver. Okay? Remember, here there is a full network. Routers, switches, you name it. Okay? Type. When the receiver receives that segment, what the receiver will do is that it will send acknowledgement, right? So this acknowledgement, we draw it one line because the acknowledgement has a very, very small length. It's just one field or two fields, right? So this is the propagation time for the acknowledgement. Okay? Because both are signals, it doesn't matter whether it's a segment or an acknowledgement, because both of them, they get converted to a physical signal which travels over the line. Anyway, so we have 2 propagation and 1 transmission. Okay? This is for sending only one segment. For sending only one segment. Okay? So how can we calculate the performance? The performance, one way of calculating the performance of this is that how much did I consume the channel in something useful, okay, versus how much did I not consume the channel in something useful. Okay? So during this entire period, okay, what I essentially did is that I sent only one segment. Okay? But I consumed the channel for this entire period of time. Okay? So it's 1 transmission time plus 2 propagation time. Okay? And I ended up using the channel only for 1 segment. Okay? The transmission time for 1 segment, we know it, it's the length divided by the bandwidth. Assuming that the bandwidth is is almost fixed, and it's like 1 gigabits per second. So the transmission time is very small, like 8 microseconds, okay? But the propagation time is given here. It's actually 15 milliseconds to go into one direction. And that's typical. Why? Because here we're talking about the full network. We're talking about sender in Qatar, which communicates with another receiver in China. Okay, so the propagation has to pass through many networks and devices until it reaches to China, right? So that propagation time happens to be 15 milliseconds. It's given, because calculating it is very hard. But assuming that it's fixed, 15 milliseconds. So to propagation time is 30 milliseconds, which is what we call round trip time, which is the time for the signal to go to the receiver, and the receiver sends me back the acknowledgement. I need to account for 2 propagation time. But I effectively use the channel only for that period of time, that transmission time. I don't have any other choice. You do have choices. You do have other choices.
Create a window.
Yes. So if I send this segment and send another segment and send another segment, نظريا, we didn't do that. But if we do this, then essentially I consume the channel for n number of segments before I have to wait for the acknowledgement of the first segment. We didn't do this, but it's possible. Okay? How about we'll talk about this. But in order to find the utilization is the percentage of time I effectively use the channel, okay, versus the time that I wasted not transmitting anything. Okay? So that utilization is defined as follows. I use the channel for 1 transmission time, but I had to wait for round trip time plus the transmission time, okay, before I send the next segment. Okay? So I essentially, this is what we call the utilization. And the utilization, can you see the utilization how much? So I use the channel for 0.027% of the time, which is very low. Okay? So stop and wait. While it's okay, it works, but it's not performing well in any way in terms of channel utilization. Okay? But as well, if we send the segments back to back, okay, with no limitation, that's the other extreme, which will get us into the situation that, again, one sender is consuming the entire network. You cannot do that, right? So neither situation is well performing. So there must be something in the middle. So the last thing is that this is the calculation. So this is the percentage. So this means what? This means that one sender in one side of the world, this is the map of the world, okay? And this is the receiver on the other side of the world, right? And this is the channel between them. And stop and wait promotes the fact that there is only one segment on this whole channel that travels the whole world, okay? One at a time.
Which is not true.
It's not efficient خالص. Okay? So this motivates the fact, can we actually do this? The answer is yes, of course. And that's what Go Back N tries to address. Okay? So Go Back N works this way. But in order for Go Back N to work this way, it needs to add by the concept of a window and of course 2 sequence numbers will not be enough in that case. صح? Because we have to really distinguish between not only 2 packets in different packets. Right? So we cannot accommodate having only 2 sequence numbers. We need more than that. Okay? So that's what we will try to achieve. So Go Back N tries to achieve this. If N here is the number of segments that I can send before I expect to receive any acknowledgement for the first segment. Okay? Which essentially converts that utilization to N times L over R divided by RTT plus L over R, which means that the utilization is linearly multiplied by N. And this is perfect, this is good. So as N increases, the utilization of the channel increases linearly, proportional على طول. Okay? So again, N is another careful design parameter that we need to calculate, because if N is 1, we know it's inefficient. If N is infinity, we know that the network will definitely be congested for sure. صح? N cannot be infinity. Okay? But we know if it's 1, it's inefficient. So N has to be also reasonably designed. So we know 2 parameters now that we need to design carefully: the timeout and this N. تمام كده؟ Anything not clear? Okay. So so this is the example. So this is N now. If I send 3 segments before I expect 1 acknowledgement to arrive, then essentially I multiply the utilization by 3. If it's 4, I multiply by 4. Okay? But if it's like 10,000, the problem here will become by the other way around. I send, and I cannot cope with the amount of acknowledgement, or maybe I will not cope. The router buffers will be filled, and the network will start to be congested, and I will have a chaotic situation. Okay? I will congest the network, or I overwhelm the receiver, so I'll create problems. Okay? So N is also a very important parameter that I need to be careful with. ماشي كده؟ So we'll talk about that, go back in next time, inshallah. Any questions? تمام كده؟